Welcome viewers, in this video we will see the solved problem based on the DC transient response of RL circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the problem. The statement of problem is a DC voltage of 100 voltage is applied to a series RL circuit with R equal to 25 ohm. What will be the current in the circuit at twice the time constant? So this is the RL series circuit. R value is given 25 ohm, applied voltage is 100. We need to find the current in the circuit. One more data available is twice the time constant. The time is t equal to twice the time constant, right? So based on that, we'll go to the solution. As the voltage source in the circuit, the expression for rise in current is given by, for this series RL circuit, the current I equal to I into 1 minus e power t divided by tau. So the t is the time, tau is the time constant for the RL circuit, time constant of RL circuit. So this is the equation for current for this given RL series circuit, right? In this we need to find the I value and this tau, what is the time constant. The time constant already given as twice the time constant. So I equal to E divided by R. These two data are available. E is the 100, R is 25, so 4 amperes. So steady current, steady state current I equal to 4 amperes. And given that T equal to 2 times of time constant, 2 tau. One more data what we have, the current in the circuit at twice the time constant, 2 times of time constant. This is tau. So T equal to 2 tau. So the given expression is I equal to I of 1 minus e power minus t by tau. Now the t value is available. T is given as 2 tau. So replace this t by 2 tau. Already one tau is there, so got cancelled. So e power minus 2. Right, the I value is 4. So I equal to 4 of 1 minus e power minus 2. By simplifying the expression, we got I equal to 3.46 amperes, right? So it's a very simple problem. We are directly using this formula. In this formula, I value is calculated as E by R. These two data are available. The time constant T, the time T and time constant T, the relation is given. T equal to 2 times of tau. Based on that, this time constant got cancelled. We got e power minus 2, so that we can easily solve the problem. The final answer is 3.46 amperes. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the solved problem based on the DC transient response of RL circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the problem. The problem statement is, in the circuit zone, find the expression for transient current and initial rate of growth of the transient current. We need to find the two values, transient current and initial rate of growth of the transient current. The given circuit is the RL series circuit. R value is 5 ohm. The inductor value is 3 Henry. The current, transient current is flowing here. The applied voltage is 100. The rise in current I naught is 6 amperes. So we need to find the transient current and initial rate of the current. So from this circuit diagram, we can apply the Kirchhoff's voltage law. Can get, while applying Kirchhoff's voltage law, what is that? The applied voltage is equal to sum of potential drop across resistor and inductor, right? This is the potential rise. These two are potential drop. Potential rise is equal to sum of potential drop. That is, the voltage across 5 ohm resistor is 5 into I. This current I is flowing. Then voltage across the 3 ohm Henry, 3 Henry inductor is 3 into di by dt. That is equal to applied voltage 100 u of t. Right? So applied voltage equal to resistive drop plus inductive drop, right? So from that, as I of naught is directed opposite to that of I of t. So I of t is treated as negative, that is I naught is minus 6. See the direction here. It is going upward. This current is going downwards. Both are opposite. So based on that, I naught value is taken as minus 6 amperes. Here given 6 ampere, but because of the direction, based on the direction, we can say this I of naught, that is called the initial current, is 6 ampere. Now we'll take the Laplace transform of the first equation 1, in order to convert the t domain into s domain. Again, while taking inverse Laplace, we'll get the transient current. Right. Now we'll take the Laplace transform of equation 1. So 5 is constant. I means I of t. While taking Laplace, it becomes I of s plus 3 into di by dt. Laplace transform of di by dt is s into I of s minus I of 0. This is initial current. From this, we need to subtract the initial current. Then 100. Laplace transform of 100 is 100 by s. Right? So now we taken the Laplace transform. In this is the initial current. We already decided initial current based on the direction is minus 6 amperes. Right? So this I of naught is replaced by minus 6. Already here one minus is available. So it becomes plus 6. Right. Now we can go for further simplification. We can multiply 3 inside. So 5 I of s plus 3 s I of s plus 3 into 6 is 18, that is equal to 100 by s. Right. Now I of s is available commonly. I of s is available in these two terms. So we'll take I of s outside. So that 5, this 5 plus 3s plus 18 equal to 100 minus s. Now we'll bring this 18 that side. So that 100 by s minus 18. So take the LCM. So 100 minus 18 into s. 18 and s is multiplied. So I of s equal to 5 plus 3s equal to 100 minus 18s divided by s. Now we'll go for the further simplification. So I of s equal to 100 minus 18s by s. This 5 plus 3s is brought in the denominator. So that we got the value of I of s, the expression for I of s. You take this equation number 2. So I of s equal to, we can rewrite minus 18s plus 100 divided by s into 5 plus 3s. Right. So in order to take the inverse Laplace, then only we can get the transient current I of t. We need to take the inverse Laplace of this expression. But we cannot take this, so it should be splitted. The s term should be splitted. Then only we can take the inverse Laplace. So that is done by partial fraction. This is called a partial fraction. This expression is written as a by s plus b divided by 3s plus 5. Right? So that s terms are splitted. So finding the value of a and b, we can take the inverse Laplace of this expression. Right. So this a by s plus b by 3s plus 5. Right. So this expression is written here. So here we will take the LCM. We will take the LCM, s into 3s plus 5. So here only s is available. So a is multiplied with 3s plus 5. Here only 3s 5 is available. So it is multiplied by s. Right. So these two are common term. In this common term only s available. So a multiplied with 3s plus 5. In b 3s plus 5 is available. So multiplied by s. Now these terms are got cancelled. On both the side, these terms are got cancelled. So what we have, minus 18s plus 100 equal to a of 3s plus 5 plus bs. Right. Now we got the equation number 3. This is equation number 3. Now our aim is to find the value of a and b. We need to find the value of a and b. That can be substituted in 2a, so that we can go for inverse Laplace. How to find the value of a and b is very simple. If you put s equal to 0, this b term is cancelled. B term becomes 0, so that we can find a. Similarly, if 3s plus 5 equal to 0, so s equal to minus 5 by 3. By substituting s equal to minus 5 by 3, this term becomes 0, so that we can find b. Right. So we need to see that what is the value we need to substitute, so that first a got cancelled or b got cancelled. So s equal to 0 means b term got cancelled. S equal to minus 5 by 3 means a term got cancelled. We can find b. So first put s equal to 0 in equation number 3. So minus 18 into S. S is 0 plus 100 equal to A of 3 into S. S is 0 plus 5 plus BS. BS is 0. Right? This S is replaced by 0. So this term is 0, only 100 equal to 5. This term is 0. So 5 is there. So 5A. This term also 0. So 100 equal to 5A. So that A equal to 100 by 5. A equal to 20. Now we calculated the value of A as 20. Right. Then we'll go for the B. Right. So I will explain this 3S plus 5. 3S plus 5. 3S plus 5. If you want to make this term 0 means we'll equate 0. 3S plus 5 equal to 0. So 3S equal to minus 5. So S equal to minus 5 by 3. So if you put S equal to minus 5 by 3, the term got cancelled. So that we can find B. So that we are substituting S equal to minus 5 by 3. So it is obtained from this equation. Right. So by putting S equal to minus 5 by 3 in equation 3, what happened? Minus 18 into S. S is minus 5 by 3 plus 100 equal to A of 3S. 3 into S. S is minus 5 by 3 plus 5 plus BS. S is minus 5 by 3. Now S value is substituted. Right. So this got 6 times. 18 by 3 6 times. So 6 into 5 30. Minus available 2 times. So it become plus 100. So this 3 got cancelled. Minus 5 plus 5. So this term is 0. Here minus 5 by 3 B. Right. So 30 plus 100 130. That is equal to minus 5 by 3B. So B equal to 30 into 3 divided by 5. 30 into 3 divided by 5. This 3 is multiplied here. 5 is brought in the denominator. Negative is available. By simplifying this, what we got? 78. Right? B value is 78. A value we already calculated as 20. B value is 70. Now we can substitute these two values in the equation 2A. So I of S equal to A by S, that is 20 by S, minus B by 3S plus 5. B is minus 78. Right. Now we got this expression. Now we'll go for further simplification. Then we'll take the inverse Laplace. So this 3 and 78 simplified, it goes 26 times. So 20 divided by S minus 26 divided by S plus 5 by 3. Now it is available in a S terms are separately available. So we can easily take the inverse Laplace on both the side. Taking inverse, not a Laplace, inverse Laplace. Taking inverse Laplace on both the sides. So I of S become I of t. That is equal to 20. 1 divided by S is 1. So 20 minus 26. 1 divided by S plus 5 by 3 is e power minus 5 by 3 t. So that is based on this formula. This is based on this formula. E power minus a t equal to 1 divided by S plus a. This is a formula. This a is nothing but now 5 by 3. A is the 5 by 3. So S plus 5 by 3. So that e power minus a t. E power minus 5 by 3 t. Right. A is nothing but minus 5 by 3 t. So based on the formula it is written. Right. I of t equal to 20 minus 26 e power minus 5 by 3 t. This is the expression for current, transient current. Right. Now we'll see the growth of the current. One more question is available. To find the initial rate of growth of I. Right. So what we need to do, we need to differentiate this equation with respect to t by substituting t equal to 0. So that we'll get the initial rate of current. So that instead differentiation of 20 is 0 minus 26. Differentiation of e power minus 5 by 3 t is minus 5 by 3 t, 5 by 3 into e power minus 5 by 3 t. At t equal to 0, we need to substitute t equal to 0. So while substituting t equal to 0, after simplification we got 43.33 ampere per second. Right, we have to substitute t equal to 0 here. So it becomes e power 0. Only what we have 26 into 5 by 3. Negative available 2 times. So 26 into 5 divided by 3, we got 43.33 ampere per second. So in this video we discussed the solved problem based on the RL, transient circuit. We calculated the transient current as well as initial rate of growth of current. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the solved problem based on the DC transient response of RL circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. DC transient response of RL circuit, solved problem 3. Now refer the circuit diagram. So this is a circuit diagram available. Two voltage sources, 50 voltage and 10 voltage, is connected by the switches there. Position 1, position 2. It is connected with RL circuit, resistance and inductance, 5 ohm and 2 Henry. So the statement is, in the circuit, switch S is in position 1 for a long time and brought to position 2 at t equal to 0. Determine the circuit current. So there are two positions available. In position 1, the switch is kept for long time, so that inductor will store the energy. After that, the switch is positioned at position 2 at t equal to 0. For that, we need to determine the circuit current. What is the current flowing through the circuit? Now we'll see the, after closing the switch to the position 2, we can apply the Kirchhoff's voltage law to get the equation. We can apply Kirchhoff's voltage law, KVL, after closing the position 2. So after position 2, closing the position 2, what happened? This is a voltage source, 10 voltage. The circuit elements are resistor and inductor. So the voltage source is equal to voltage drop across resistor and inductor. That is the Kirchhoff's voltage law. Voltage rise equal to voltage drop. Voltage rise is 10 voltage. Voltage drop is voltage drop across resistor and inductor. So based on that, we can write this equation. The current flowing through the circuit is I. So 10 voltage equal to voltage drop across resistor. V equal to I into R. R is 5 ohm, I is current I, 5I. And the drop across inductor is 2 di by dt. That is equal to 10. So equation number 1. So we are applying Kirchhoff's voltage law, that is equal to voltage rise equal to voltage drop across resistor and inductor. Now we can take the Laplace transformation on both the sides in order to convert the t domain into s domain. So taking Laplace transform on both the sides. So 5i is nothing but 5i of s plus 2 into di by dt. Laplace transform of di by dt is s into I of s. Laplace transform of differentiation is s into I of s. Integral means I of s divided by s. Minus initial current. I0 plus is nothing but the initial current. We need to subtract the initial charge, initial current or initial charge. That is equal to 10 divided by s. Differentiate Laplace transform of constant is 1 by s. So it is 10 by s. Now we'll see what is this I0 plus. We need to subtract the initial current. Now we'll see what is the I0 plus current. I0 plus is the current passing through the circuit just after the circuit switch is in position 2. After changing the position from 1 to 2, the current flowing through the circuit. Since the inductor does not allow sudden change in current, so this current is equal to steady state current when the switch was in position 1. While changing from position 1 to 2, the current flow is the I0 plus, but the inductor will not allow sudden change in current. Slowly it will increase or decrease. So this current is nothing but the current when the switch is at position 1, because the switch was in position 1 for long time. So the current flowing during the position 1 is same as the position 2. Now we'll find the current when it is in the position 1. I0 plus equal to V by R. V is 50 voltage. At position 1 is connected to 50 voltage, position 2 10 voltage, divided by resistor value 5. So it is 10 ampere. So I0 plus value is 10 ampere. So this current is nothing but current flowing during the position, which is kept at position 1, that is same as position 2, because inductor does not allow sudden change in current. Now we can substitute this value I0 plus equal to 10 ampere in the equation 2. In this we can substitute. So substitute 3 in equation 2. Substitute the current value in equation 2. So 5 I of s plus 2 into s into I of s minus I0 plus equal to 10 by s. This is the equation 2. Here we need to substitute I0 plus equal to 10. Right? So multiply inside now. 5 I of s plus 2 s I of s minus 2 into 10, 20 equal to 10 divided by s. Now I will bring this 10 minus 20 that side. So it become plus 20. Now here take the I of s common. So it is 5 plus 2 I of 2 into s equal to, here take the s common. So that s is available here. So 10 plus, here s is not there. So it is multiplied 20s. 10 plus 20 s divided by s. Right. So that from that we can find the I of s value. Bring this term in the denominator. 10 plus 20s divided by s into 5 plus 2s. Right. Now we need to take the inverse Laplace of this equation so that we can determine the circuit current. So while taking inverse Laplace, we can get the again t domain. Initially t domain converted into s domain by Laplace transform. Again s domain converted into t domain by inverse Laplace. But we cannot take the inverse Laplace directly here. It should be in the particular format. Then only we can take the inverse Laplace. So that this equation can be written by using the partial fraction technique. We need to split like this. So that this time we can easily take the inverse Laplace. This time we can easily take the inverse Laplace. Right? So 10 plus 20s divided by s into 5 plus 2s equal to, certain formulas are available, certain formats are available. Accordingly it is written as a by s plus b divided by 2s plus 5. These two terms are splitted. A by s plus b by 2s plus 5. Now take this term common. Here already this term is available. Now we will take the LCM. S into 2s plus 5. Here s is available. So we multiply with 2s plus 5. Here 2s plus 5 is available. So multiply by s. Right? Now it is we will take the LCM. Now it is becoming a single term. So these two terms are cancelled. This term is cancelled on both the sides. So what we have finally, 10 plus 20s equal to a into 2s plus 5 plus b into s. Right. Now finally we got the simplified expression. Next our aim is to find the value of a and b, so that we can go for inverse Laplace. How to find the a and b value? From this value itself we can identify. If you substitute s equal to 0, this term is 0, so that we can find a value. Similarly, if you substitute 2s plus 5 equal to 0, so that s equal to minus 5 by 2. If you substitute minus 5 by 2 here, this term got 0, so that we can find b value. So based on that, first we will substitute s equal to 0. S equal to 0 is substituted here. So 10 plus 20 into 0 plus a of 2 into 0 plus 5 plus b into 0. Right? So this s is substituted as 0. 10 plus 20 into 0 plus a into 2 into 0 plus 5 plus b into 0. Right? So this term is 0, only 10 is available. This term also 0, this term also 0, only 5 is available. A5. 5 is A5 means 5a. 10 equal to 5a, so a equal to 10 by 5 is a equal to 2. Right? By substituting s equal to 0, this term is becomes 0, so that we are easily calculate the value of a equal to 2. Similarly, in order to eliminate this value, we are going to substitute s equal to minus 5 by 2. Right? So 10 plus 20 into s is minus 5 by 2 equal to a of 2 into s is minus 5 by 2 plus 5 plus b into s is minus 5 by 2. Right? So 10 minus, here minus is there, minus, here 20 divided by 2, 10. 10 into 5, 50. Right? See, this 2 got cancelled, minus 5. Here plus 5. So totally this term become 0. Here minus 5p by 2. Right? So 10 minus 50 equal to minus of 5b by 2. Now we can go for the further simplification. So 10 minus 50 minus 40 equal to minus 5b by 2. So minus minus got cancelled. So b is nothing but multiply this. 40 into 2 divided by 5. This 2 is brought into numerator, 5 is brought into denominator. So 40 into 2 divided by 5. So this 5 goes 8 times. So 8 into 2, 16. So B value is, now we got 16. Right? Now we calculated the A and B value that we can substitute in this equation number 4. So I of s equal to A by S plus B divided by 2S plus 5. Now A is calculated as 2 by S plus B is 16 divided by 2S plus 5. So that is equal to 2 by S plus 16. We can take this 2 outside. We need to bring in the S format, S plus, so that this 2 is taken outside. So S plus 5. Here the 2 is not there, so 5 by 2. Right? So it is in the format S plus A. S plus A. Here 2S is there, so that we have to take the 2 outside. It is in the standard format. Now we can easily take the inverse Laplace on the both the side. So 2 by S is nothing but 2. Right? Already the 10, the inverse Laplace of 10 is 10 by S. The inverse Laplace of 2 by S is 2 plus 16 by 2 is there. 1 divided by S plus A. Here the formula is there. 1 divided by S plus A is e power minus AT. So based on that, 1 divided by S plus 5 by 2 is e power minus 5 by 2. Here plus mean, here minus. Here plus mean minus. Here minus mean plus. Right? So based on that, this 1 divided by S plus 5 by 2 is written as e power minus 5 by 2. 16 by 2 is already available, constant. So 2 plus 16 by 2 is 8. E power 5 by 2 is minus 2.5 T. So this is the final circuit current in terms of T. 2 plus 8 e power minus 2.5 T. Right? In order to bring this term S plus A, we are taking this 2 outside. Right? So by comparing these two, we can easily write this. So in this video, we discussed the solved problem based on the RL circuit, DC transient response of RL circuit. We calculated the circuit current I of t in terms of the current, in terms of the time we calculated by taking the inverse Laplace. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the solved problem based on the DC transient response of RL circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, DC transient of RL circuit, problem number 4. First we will refer the circuit diagram. So this is the circuit diagram given. 120 voltage source is available. There are two positions are there. 20 ohm resistor is connected. Here coil is there, RL, resistor and inductor, 10 Henry and 40 Henry. Here one more resistor RD is available. While connecting at position 1, RD is disconnected. Only this resistor and coil is connected. When the switch is connected to second position, this RD also included. RD, 20 ohm resistor and coil in the position 2. Now we'll see the statement of the problem. What is given in the statement of the problem. In the circuit shown below, the switch was initially in the position 1. Initially kept in the position 1. So RD is not included. We need to find the 3 subdivision. For RD equal to 500, find the voltage across the coil the instant at which the switch is changed to position 2. Initially at position 1, now position 2 is changed. RD value is given 500. We need to find the voltage across the coil. So first question. Calculate the value of RD for the voltage across the coil reduced to 120 voltage at the instant of switching. Here RD value is given. We need to find the voltage. Here voltage is reduced to 120. For that we need to find RD value. With the value of RD in case, find the time taken to dissipate 95% of energy stored. That is the third question. Right? The RD value what is given in the same case is there. We need to take the same value of RD. For that we need to find energy stored to dissipate 90% of the stored energy. Right. Now we'll see the first question. The RD value is given. We need to find the voltage across the coil. So here in this circuit, While connecting to position 2, what are the things we have? RD is there, 20 ohm resistor is there, and coil is available. So here the applied voltage is 0 here. We need to apply the Kirchhoff's voltage law. Applied voltage is 0. That is 0 equal to voltage drop across these three elements, RD, 20 ohm resistor and coil, that is equal to 0. Voltage source is not available. So based on that we can write the Kirchhoff's voltage law. First we will find the steady state current when the switch is in position 1. So that is equal to 120 voltage is applied divided by 20 plus 40. So 120 divided by 60, it is 2 ampere. So when it is in the position 1, switch is at position 1, applied voltage is 120. The resistor is this 20 ohm resistor and 40 ohm resistor, 20 plus 40. So 120 divided by 20 plus 40, 120 divided by 60 is 2 ampere. So now we will calculate the current. Now we can go for the Kirchhoff's voltage law. Now with RD is 500 is given in the first division. The switch is changed to position 2. Now we can apply the Kirchhoff's voltage law, KVL. So there is a voltage source is not available, 0. Voltage rise equal to voltage drop. Voltage rise is 0. First 2 into 500, RD, 2 into 500. Another resistor, 2 into 20. This 2 is nothing but current. I into R. This is I into RD. This is I into R. Voltage across the coil we need to find. That is the question. That is equal to 0. So 2 into 500, 1000. 2 into 20, 40. Plus voltage across the coil equal to 0. So 1040 equal to voltage across the coil equal to 0. Bring this 1040 that side, minus it become minus 1040 voltage. The sign indicates that voltage is in opposite direction. The voltage across the coil is opposite direction. So the first division we calculated the voltage across the coil minus 1040 voltage. I will go to the second subdivision. So in the second subdivision we need to find the RD value. The voltage is reduced to 120. Right? The voltage is given, we need to find RD value. Same KVL is applied. Voltage drop across RD is RD into 2 plus 20 ohm resistor, 20 ohm into 2 ampere minus the coil is given. The voltage across the coil is minus 120, that is equal to 0. So 2 RD plus 40 minus 120 equal to 0. 2 RD, 40 minus 120 is minus 80. Bring this 80 that side, so it become plus 80. So RD equal to 80 divided by 2, it is 40 ampere, 40 ohm. Right? So second subdivision, voltage is given. We calculated the RD by using the same formula, Kirchhoff's voltage law. Then we need to find the energy stored. Then we need to find energy dissipated, 90% of energy dissipated. So first we will find the energy stored. Then we will find 90% of what is the current required to determine the 90%. So energy stored equal to half Li square. We know that energy stored in the coil is half Li square. Capacitor means half CV square. Here half Li square. Inductor based on current. So half into inductor value is 10 into current is 2 ampere that we calculated initially. So 2 square means 4. 4 divided by 2, 2. 2 into 10, 20 joules. Right? So the 20 joules is the energy stored. Now we'll see what happened if it is 95%. Given that 95% of energy is dissipated. So the residual energy is 5%. So that energy stored equal to 0.05 into 20 equal to 1 joule. So this residual energy is 1 joule. Out of 100, 95 is dissipated, 5 is residual energy. That 5 is nothing but 5 means 5 divided by 100, 0.05 into 20, total energy 20, 1 joule. So half Li square equal to residual energy. From that we can find the current value. Half into L value is 10, I is not available. I we need to find. Right? That is the question. We need to find the question is time taken we need to find. So first we are calculating current. So 1 by 2 plus 10 into 10 into I square equal to 1. So this goes 2 times. So 5 I square equal to 1, I square equal to 1 divided by 5, I equal to square root of 1 divided by 5 0.447 ampere. Finally, we need to find the current time taken. What is the time taken to reach 95%? Now we calculated the current. Now we'll see the next thing. This case, a decay of current in RL combination. The equation is for I is given by. So it is decaying. So there is two things available, charging and discharging. Here this is coming under second case, this decaying. So I equal to I e power minus R by L t. This is standard equation. This derivation is available separately. So here I is 2 amperes. R is nothing but 40 plus 40 plus 20 equal to 100 ohm. Right? So this 40 plus 40 is nothing but it is given in the problem itself. This 20 ohm is already given. 40 ohm is the resistance of the coil. This 40 is nothing but RD value. So we need to RD value available in the second case. We are used for third case also. First case RD given 500 ohm. Second case we calculated the RD as 40 ohm. 40 ohm. That 40 ohm we are using this. That is given in the problem itself. What is calculated in the second case? The same value of RD. So RD 40, this resistor value of the coil 40 and one more resistor 20, so it is 100 ohm. L is already given 10 Henry. Now we can substitute all the value. I equal to I e power minus R by L t. So I is 0.447 that we calculated here equal to 2 ampere. This is steady state current. E power minus 100 by 10 into t. Now we can go for further simplification. So 0.447 equal to 2 e power minus 10 by t. That is minus 100 by 10 is 10t. Bring these two in the denominator. 0.447 divided by 2, that is 0.2235. That is equal to e power minus 10t. Now from there, how to find the t value? We need to take the log on both the sides. Log with base e. Multiply with the log. Log 0.2235 equal to log to the base e power minus 10t. So this value log 0.2235 is minus 1.5. This e power minus 10t will be come in the in this position beginning. So log b base e, right? E power, this power will come in the front. Right? Log e base e is 1. That value is 1. So that minus 1.5 equal to minus 10t. So minus minus got cancelled. 1.5 divided by 10 equal to t. So t equal to 1.5 divided by 10 means 0.15 seconds. So time taken to dissipate 95% is 0.15 seconds. So in this problem we discuss the RL circuit. 3 different cases we discussed. First case is we need to find the voltage across the coil for RD value is given. Second case, voltage across the coil is reduced to minus 120. For that we find the RD value. With this RD value we calculated the energy dissipated. 95% of energy dissipated. Time taken is calculated 0.15. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the DC transient response of RL circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. DC transient response of RL circuit, problem number 5. So this is the given circuit. Here the switch is available. 2 voltage sources are available. 12 voltage, 24 voltage, RL. Resistor and inductor is connected in series. If we close the switch, it becomes short circuit. Only 12 voltage is applied. If you open the switch, this 12 voltage and 24 voltage is connected to the circuit. That is the given based on the switch. You see the statement. Find the current in the circuit shown below at the instant t. After opening the switch, if a current I is current of I ampere had been passing through the circuit at the time of opening. So we need to find the current in the circuit after at the instant after opening the switch. So while opening the switch, the current I is flowing through the circuit, right? So this I of t, we need to find what is the I of t. So the switch is closed at the time when current is flowing, that is called a initial current. The switch is open, we need to find what is the current, that is called a transient current, right? So here we are going to apply the Kirchhoff's voltage law, KVL. What is the KVL? Is voltage rise. This voltage source is a voltage rise. This is voltage drop. Voltage rise equal to voltage drop. Otherwise, applied voltage equal to drop across the elements. So here 12 voltage and 24 voltage. The switch is open. So 12 voltage is added with 24 voltage. Total 36 voltage will be there. That is equal to resistive drop. Resistive drop means 6 into I. Inductive drop 5 into di by dt. So that is the basic equation we are going to use. We are going to apply the Kirchhoff's voltage law. Now we'll see the solution. So after t seconds of opening the switch, applying the KVL, that is equal to this is a basic equation. Applied voltage equal to resistive drop plus inductive drop. I into R plus L di by dt, that is equal to E. Here R value is 6 ohm, L value is 5 Henry. E is the total voltage in the circuit after opening the switch. So after opening the switch, 12 and 24 are connected in series. So that become 36 voltage. And also I naught plus is called a initial current, that is equal to 1 ampere. Right, in the problem itself it is given 1 ampere. Right. Now we'll substitute all these value in the equation 1. So that IR plus L di by dt equal to E. I value is I into R. R value is 6 ohm. L value is 5 Henry. Di by dt equal to 36. That is 6I plus 5 di by dt equal to 36. Now we need to take the Laplace transform on both the sides, so that t domain will be converted into s domain. Now we will take the Laplace transform on both sides. So while taking the Laplace transform, 6 into I of s, that is 6I is converted into 6 into I of s. 5 di by dt is converted as 5 into s into I of s. Di by dt, the Laplace transform is s into I of s minus initial current I of 0 plus, that is equal to 36 divided by s. Laplace transform of 36 is 36 divided by s. Laplace of constant is 1 by s based on that. So 6 I of s plus 5 into s into I of s, this is nothing but a initial current. It is given as 1 in the problem itself, that is equal to 36 divided by s. So we multiply inside, so 6 I of s plus 5 into s I of s minus 1 into 5 minus 5 equal to 36 plus 5. I will bring this 5 on that side. So 6 I of s plus 5s I of s equal to 36 divided by s plus 5. I will take this I of s common. So it become 6 plus 5s. Here we will take s as a LCM. Right? S is there. So it is 36 plus, here s is not available. So it is multiplied by s, 5s. Right? So 36 plus 5s divided by s. Now we will bring this term in the denominator, so that we will got the expression for I of s. So I of s equal to 5s plus 36 divided by s into 5s plus x. Right? This 6 plus 5s is brought in the denominator. Now we will take this equation number 2. Now we need to take the inverse Laplace of I of s, so that we will get I of t. But we cannot take the inverse Laplace in this form. We need to convert into the required format. That can be done by partial fraction technique. Like this, k1 divided by s plus k2 divided by 5s plus 6. So this can be easily, we can take the inverse Laplace transform. So by using the partial fraction technique, this term is written as k1 divided by s plus k2 divided by 5s plus x, 6. I will take the LCM here, s into 5s plus 6. Here only s is there, so it is multiplied by 5s plus 6. Here 5s plus 6 is there, so multiplied by s. Right. Now on both the side this term is available, so got cancelled. So what is available here? 5s plus 36 equal to k1 into 5s plus 6 plus k2 into s. We will take this equation number 3. So the next step is, our aim is to find the value of K1 and K2. How will you find K1 and K2? If you put S equal to 0, this term can't cancel. So we can find K1. Similarly, if you put 5s plus 6, 5s plus 6 is there. If you put s equal to minus 6 by 5, this term got cancelled, we can find K2. So from the coefficient of this value, we can find what is the value we need to substitute. S equal to 0 means K2 got cancelled, we can find K1. If s equal to minus 6 by 5 means K1 got cancelled, we can find K2. So first to put s equal to 0 in the equation number 3. Here we need to put 0. So 5 into 0 plus 36 equal to K1, 5 into 0 plus 6 plus K2 into 0. Right? So 5 into 0 is 0. Only we have 36 equal to, this term also 0. 6 is there. So 6 K1. This term also 0. So 36 equal to 6 K1. So that K1 equal to 36 divided by 6. That is equal to 6. K1 equal to 6. So by putting s equal to 0, we calculated K1 equal to 6. Now we'll see the s equal to minus 6 by 5, so that we can able to find the K2 value. Now we'll see how to find the K2 value. So here put s equal to minus 6 by 5 in the equation number 3. So 5 into minus 6 by 5 plus 36 equal to K1 into 5. This s is minus 6 by 5 plus 6 plus K2 into s. K2 into minus 6 by 5. Right. 5 got cancelled, minus 6 plus 36. See, this 5 and 5 got cancelled, minus 6 is there, here plus 6 is there. So total is 0. That is our aim. So by putting minus 6 by 5, this term got 0. So this is minus is there. Minus 6 by 5 equal to K2. So minus 6 plus 36 is 30 equal to minus 6 by 5 K2. Now cross multiply this. 30 into 5 divided by 6. Minus is there. So minus 30 into 5 divided by 6. So it goes 5 times. So 5 into 5, 25. Minus 25. So that K2 equal to minus 25. Now we calculated K1 as well as K2. K1 is 6. K2 is minus 25. So based on this value, we can write the equation number 2. Second equation can be written as I of s equal to K1 by s plus K2 by 5s plus 6. So K1 is 6. 6 by s minus 25 divided by minus 25 divided by 5s plus 6. Right. 6 by s minus, you will take this 5 outside. So we need the standard form s plus a, s plus b, like that. If anything is available with s, that should be taken outside so that we can brought into the standard form. So that 5 is taken outside. So s plus 6 is there, only 6 is there. So 6 by 5. Right. So this 5 got cancelled, 5 times is available. Right. So it is nothing but 5 divided by s plus 6 by 5. Right. Now we'll take the inverse Laplace transform on both the sides. Right. 6 by s is nothing but 6. We already 36. Taking Laplace, it is 36 divided by 6. So 6 divided by 6, while taking inverse, it is 6. Right. Minus, this is 5 is there, minus 5. So this can be written based on this. 1 divided by s plus a equal to e power minus at. So here a is nothing but 6 by 5. So s plus 6 by 5 equal to e power minus 6 by 5 t. Right. Here s plus a mean e power minus. S minus a mean e power plus at. That is the inverse Laplace transform formula. Right. So here a is 6 by 5. So minus 6 by 5 t. So I of t equal to 6 minus 5 e power minus 6 by 5 t. Minus 6 by 5 while dividing, it become minus 1.2 t. So this is the transient current required after opening the switch. I of t equal to 6 minus 5 e power minus 1.2 t. Right. So in this video we discussed the RL transient circuit based on the DC transient. We solve the problem. Initially the switch is closed. After switch is open, we have calculated the current flowing through the circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the DC transient response RC circuit solved problem 1. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic DC transient response of RC circuit, resistance and capacitance. The first problem. First we will refer the circuit diagram. So this is a circuit diagram given. Supply voltage V, the switch is available and R1 is connected across the supply. R and C connected in series, resistor and capacitor connected in series, R1 and R2. The problem is we need to find the time taken to reach the current to 25 milliampere from the supply. Initially some current will be there. So the total current should reach us 25 milliampere. For that we need to find what is the time taken by the supply voltage, supply. So we'll see the statement of the problem. Find how long it takes after the key is closed before the total current from the supply reaches 25 milliampere. So our aim is to find the time taken to reach the current 25 milliampere from the supply. The supply voltage is 10 voltage, R1 value is 500 ohm, R2 value is 700 ohm and capacitor is 100 microfarad. So these are all the data given. So in this solution, the I1 will take, I1 is the current through the R1 because it is branch there. So two branches available. So total current I equal to I1 plus I2. I1 is the current through the resistor R1. R2 is the current through the capacitor after t seconds of closing the switch. Right. So the I1 we can easily calculate V by R1. V is given 10 voltage, R1 is 500 ampere. So it is 20 milliampere. So current flowing through the resistor R1, I1 is 20 milliampere. Now we'll refer the diagram. We need to find the I2 value. So given that the total current is 25 milliampere. So by using Kirchhoff's current law, I equal to I1 plus I2. Here the total current that is divided into I1 and I2. Right. I2 what we need, so that we'll bring this term I1 that side, so that I2 equal to I minus I1. I is 25 milliampere total current. I2 I1 just now we calculated 20 milliampere. So it is I2 is 5 milliampere. So now we know the I1 value, I2 value. I1 is 20 milliampere, I2 is 5 milliampere. Right. So our aim is to find the time taken. So we will see the what is the alternate expression for transient current. So one more expression available for transient current, I2 is nothing but I2 equal to I2 e power minus t divided by R2C. So this is nothing but a transient current of the RC circuit. Separate video available for analysis of RC circuit. In that we got this expression. So that is equal to I2 is nothing but V divided by R2 e power minus t divided by R2 into C. Now we'll substitute the values. I2 equal to V2 divided by R2 e power minus t R2 into C. So I2 is nothing but 5 milliampere. 5 into 10 to the power minus 3. Voltage is 10 voltage. R2 value is 700 milliampere. E power minus t divided by R2 700 ohm. C is 100 microfarad. 100 into 10 to the power minus 6. Now we can simplify. While simplifying what we got, 5 into 10 to the power minus 3 equal to 10 divided by 700 e power minus t by 0.007. While simplifying this 0.007. Now we'll go for the further simplification. In order to find the time taken t, here the e power is there. So we can take the log. We'll take the log on both the side with base e. Log with base e will take on both the side, right? So it is before that it is simplified. So this e power minus t by 0.07, this 10 divided by 700 is brought to this side. So 700 divided by 10. So it is 0.37 equal to e power minus t by 0.07, right? The term available here 10 divided by 700 is brought to this side. Now we can take the log on both the sides because the t is available with e power. So you cannot simplify this without taking the log. So log is taken on both the sides. Log with base e. So log 0.35 equal to log of e power minus t by 0.007 with base e. So log 0.357 is minus 1.05. So e power will come in the front side. So minus t by 0.007 log e with base e. Right. So this term, for example, log e power minus x means it will come minus x into log e power. Right. So we can go for the further simplification. Minus 0.105 equal to minus t divided by 0.07. Log e but base e is nothing but the value is 1. We know that log e with base is the value is 1. Now we can go for further simplification. Right, t equal to minus 1.05 into divided by 0.007. So here it is not divided by, it is multiplied by 0.07. Right. So it is multiplied, not divided. So minus 1.05 into 0.07 equal to minus t. Minus available on both the sides. So 1.05 into 0.07 is 0.0735. So the current t is 0.0735 seconds. So the time taken to reach the 25 milliampere is 0.0735 seconds. So in this video we discussed the RC circuit, DC transient response of RC circuit. We calculated the time taken to reach the 25 milliampere from the source. Subscribe to the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the DC transient response of RC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, transient response, DC transient response of RC circuit. We need to see the diagram. So this is a given diagram. The voltage source is available. R and C, resistor and capacitor connected in series. Resistor value is 1 ohm, capacitor value is 5 farad. So this is a transient current, switch is available. The statement of the problem is, for the circuit shown below, the initial charge in the capacitor is 25 microfarad. Before closing the switch, the initial charge available in the capacitor is 25 microfarad. The switch is closed at t equal to 0. Find transient current. Right? Initially 25 microfarad is available in the capacitor. So after closing the switch at t equal to 0, we need to find the transient current, I of t. Right. So in this we are going to apply the Kirchhoff's voltage law, KVL. KVL is nothing but voltage rise equal to voltage drop. This 10 voltage is the voltage rise. Voltage drop is voltage drop across resistor, voltage drop across capacitor. So this 10 voltage equal to voltage drop across resistor is I into R. I is transient current, R is 1 ohm. Drop across capacitor is 1 by C integral I dt. Right. So we will use the KVL later, so that V equal to voltage drop across resistor plus voltage drop across capacitor. So before going to the KVL, we will find the initial charges available. From that we can easily calculate the voltage, initial voltage. Let Q0 is the initial charge on the capacitor, that is given as 25 microfarad, that is 25 into 10 to the power minus 6 farad. So this initial charge and initial voltage on the capacitor is V0 equal to Q0 divided by C. These two values are available, so we can easily calculate V0. V0 equal to 25 into 10 to the power minus 6 initial charge divided by capacitor 5 farad. So it is totally 25 divided by 5 is 5. 5 into 10 to the power minus 6 voltage. So the initial voltage on the capacitor is 10 to the power 5 into 10 to the power minus 6 voltage. Now we'll go to the Kirchhoff's voltage law, KVL. After t seconds of closing the switch, apply the Kirchhoff's voltage law to the circuit. We already discussed voltage rise equal to voltage drop. Voltage drop across resistor, voltage drop across capacitor. I into R plus 1 by C integral minus infinite to t I dt equal to E. Right? I into R value is 1 plus 1 by C. C value is 5 farad. Minus infinite to t I dt equal to 10. E value is 10. So I plus 1 by 5 integral minus infinite to 0 I dt plus 1 by 5 0 to t I dt, that is equal to 10. So minus infinite to t is splitted into two intervals, minus infinite to 0, 0 to t. This minus infinite to 0 is nothing but a initial voltage. This is nothing but initial voltage V0. This is the normal transient current 0 to t. At t the switch is closed. This is initial voltage. That we already calculated 5 into 10 to the power minus 6 voltage. Here we calculated initial voltage. From initial charge and capacitor value we calculated V0. Now we can replace this term with 5 into 10 to the power minus 6 voltage. I will go for further simplification. So we will substitute this 5 into 10 to the power minus 6 initial voltage. So I plus 5 into 10 to the power minus 6 plus 1 by 5 integral 0 to t I dt equal to 10. So I plus 1 by 5 integral 0 to t I dt equal to 10. This term is brought that side. So 5 into 10 to the power minus 6. So while simplifying we got 9.99. Now we need to take the Laplace transform on both the side in order to find the transient current. Right? First we will take Laplace, then we will take inverse Laplace, so that we will get the transient current. So taking Laplace transform on both the side. So in Laplace of I is I of s. The t domain now converted into s domain. Then 1 by 5 integral 0 to t I dt. The Laplace is I of s divided by s. The Laplace of di by dt is s into I of s, differentiation. Integral means I of s divided by s. Similarly, constant 9.99 means 9.99 divided by s. That is the Laplace transform. Now we will go for the further simplification. So take this I of s outside. So it becomes 1 plus 1 divided by 5s, 5 into s. That is equal to 9.99 divided by s. Bring this term in the denominator, that side. 9.99 divided by s into 1 plus 1 divided by 5s. Multiply this s inside. So s into s plus s into 1 by 5 divided by s. This 5 s got cancelled. Right. So what we have finally, it is 9.99 divided by s plus 1 by 5. So 1 divided by 5 is 0.2. So finally we got 9.99 divided by s plus 0.2. Now by taking the inverse Laplace we can find the transient transient current in the circuit. So I will take the inverse Laplace on both the sides. I of t equal to this 9.99 is available. 1 divided by s plus 0.2 can be written as e power minus 0.2 into t. That is based on this. In Laplace inverse of 1 divided by s plus a is nothing but e power minus at. Here plus means minus, minus means plus. So this a is nothing but here 0.2. So that e power minus 0.2 t. So the transient current I of t equal to 9.99 e power minus 0.2 t. So in this video we discussed the solved problem based on the DC transient of RC circuit. We calculated the transient current in the circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the DC transient response of RC circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Problem based on the transient DC transient response of RC circuit, resistor and capacitor. We'll see the statement of the problem. A resistance R and a 2 microfarad capacitor are connected in series across a 200 volt direct supply. Across the capacitor is a neon lamp that strikes at 120 voltage. So R and C is connected in series. R value is not given. C value is 2 microfarad connected across 200 voltage, and capacitor having the neon lamp that with the voltage of 120. There are two questions available. Calculate the R to make the lamp strike of take 5 seconds after the switch has been closed. We need to find the R value when the switch is strike after 5 seconds. 5 seconds after the switch has been closed. Second question, R value is given. R is 5 mega ohm. How long it will take the lamp to strike? Right? Here we need to find the time. We need to calculate the time. R value is given. First question, R value we need to find. The time is given 5 seconds. Now we'll see the RC circuit, the TC transient of RC circuit general equation. From that we can calculate these values one by one. So the case 1 will first we'll consider the case 1. T is 5 seconds. We need to find the R value. So EC equal to E of 1 minus e power minus T1 divided by lambda 1. So this is the DC transient response of a RC circuit. Separate video available how we are getting this equation. So here the EC is 120 voltage, neon lamp. Total voltage applied across R and C is 200 ohm. T1 is given 5 seconds. Lambda 1 is nothing but C into R1, constant. There is a constant. In that C value is known, R1 we need to find. Now substitute all the values so that EC is 120, E is 200 of 1 minus e power T1 is 5 minus 5 divided by lambda 1. Right. Now bring this 200 in the denominator and go for simplification. So 0.6 equal to 1 minus e power minus 5 by lambda. Right. Now bring this e this side, 0.6 that side, so that we can go for the further simplification. So brought to this side, so the negative become positive. E power minus 5 by lambda 1 equal to 1 minus this plus 0.6 will goes to that side is minus 0.6. So totally 1 minus 0.6 is 0.4. E power minus 5 by lambda 1 equal to 0.4. Now we need to find the lambda 1 value. From that we need to find R value. So here e power is there. So we'll take the log on both the side. By taking log on both the side, we can easily identify the value of lambda 1. So take log on both the side with base e, log with base e. Log e power minus 5 by lambda 1 with base e equal to log 0.4 with base e. So this e power minus 5 by lambda will come to this side. Right? So e power will come minus 5 by lambda 1 log e with base e equal to the value of log 0.4 with base e is minus 0.916. We know that log e with base e is 1. The value is 1. So we have only minus 5 by lambda 1 equal to minus 0.916. So minus available on both the sides. So bring this lambda 1 that side, 0.916 this side. So 5 divided by 0.916 equal to lambda 1, that is 5.46. 5 divided by 0.9 is 5.46 equal to lambda 1. That is lambda 1 equal to 5.46. So from that we can find R value. This lambda 1 is nothing but C into R1. So that R1 equal to lambda 1 by C. Lambda 1 what we calculated 5.46 divided by C value is 2 microfarad. 2 into 10 to the power minus 6. So that is nothing but 2.73 into 10 to the power 6 ohm. That is 2.73 mega ohm. Right? Otherwise 2.73 into 10 to the power 6 ohm. So now we calculated the R value for a time given 5 seconds. The next question, the R value is given 5 mega ohm. For that we need to find the time taken. So in the second case, R2 value is given 5 mega ohm. We know that lambda 2 equal to C into R2, that is equal to C value is 2 microfarad, 2 into 10 to the power minus 6 into 5 mega ohm, 5 into 10 to the power 6. So this both got cancelled, 2 into 5, 10 seconds, right? So the lambda 2 is 10 seconds. But we know that e power minus 5 by lambda 1 equal to 0.4. So that is already given. So that is from the previous equation. So in the above equation we can replace lambda 1 by lambda 2, T1 by t2, so that we can get the time for second, so that we can substitute this time. E power minus t2 by lambda 2 equal to 0.4. So this is the equation already available in previous case. In that we are replacing this lambda 1 by lambda 2, this minus 5 by t2, so that we can able to find the value of t2. Now again we need to take the log on both the sides, so that we can able to find the t2 value. Lambda 2 value is known, only t2 we need to find. So log e power minus t2 by lambda 2 with base e equal to log 0.4 base e, right? So what happened, this power will come in the front side. Minus t2 divided by lambda 2 log e with base e. The value of this log 0.4 is minus 0.916, right? So log e with base e is 1, we know that. So that minus available on both the sides, so it become positive. t2 divided by lambda 2 equal to 0.916. Bring this lambda to that side. So t2 equal to 0.916 into lambda 2. Lambda 2 we know that 10. That's what we calculated, 10 seconds. So 0.916 into 10 is 9.16. So the t2 equal to nearly it is 9.2 seconds. So with R equal to 5 mega ohm, the time taken by the neon lamp is 9.2 seconds. So in this video we discuss about the DC transient response of RC circuit. Solved problem 3. So R and C is connected in series across the voltage and neon lamp is connected. In the first case, the 5 seconds time is given. For that we calculated the R value. In second case, the R value is given. For that we calculated the time taken. It is 9.2 seconds. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the solved problem based on the DC transient response of RLC circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic RLC. The solved problem based on the RLC DC transient. The problem statement is a series RLC circuit has R equal to 50 ohm, L equal to 0.2 Henry and C equal to 50 microfarad. Constant voltage of 100 is impressed upon the circuit at t equal to 0. Find the expression for transient current assuming initially released condition. So series RLC circuit is there. R, L, C value is given. Applied voltage is 100 at t equal to 0. We need to find the transient current. The initial conditions are 0, released condition. So there is no initial storage, right? Now we'll see. First we need to identify what type of circuit this one. The current is whether under damped or over damped, like that. For that the condition is available. R divided by 2L is less than 1 divided by LC. This condition is there. So we need to find these two values. If it is less than, then the current is said to be under damped. So we need to find these two values. R divided by 2L the whole square. Right, R divided by 2L the whole square. So that is nothing but R is 50, 2 into L. L is 0.2. The L equal to 0.2 Henry, that is 15,625. 1 divided by LC. 1 divided by L is 0.2. C is 50 microfarad. 50 into 10 to the power minus 6. That is 10 to the power 5. Now we calculated these two values. So from these two values it is clear that this is lesser. This value is lesser and 1 by LC is greater. In this case, the current is said to be under damped condition. Based on that, we have two values are available, alpha and beta. Alpha and beta available. Alpha equal to minus R by 2L. Beta equal to 1 divided by LC minus R divided by 2L the whole square, square root of. So R by 2L. Minus 50 divided by 2 into 0.2 minus 125. Alpha value is minus 125. Beta 1 divided by LC, square root of 1 divided by LC, that we already calculated, 10 to the power 5 minus R divided by 2L the whole square also already we calculated, 15,625. So it is 290.5. Beta and alpha values are now calculated. The roots are alpha plus JB and alpha minus JB. Right? Roots are complex conjugate. Alpha plus JB and alpha minus JB. Substituting the value of alpha and beta, we can able to find the root. That is minus 125 plus J 290.5 and minus 125 minus J 290.5. So these are all the two roots are available. Now based on that, we can go for the expression for current I of S. I of S equal to E divided by L. So this is the third case. RLC circuit, three cases available. Roots are real and equal, real and different. Third case is complex conjugate. So this is coming under complex conjugate. E divided by L, separate video available for explanation of RLC circuit. S minus alpha plus J beta into S minus alpha minus J beta. These two roots, alpha plus J beta, alpha minus J beta. Now we can substitute this value. 100, E is 100, L value is 0.2, S minus minus of minus 125 plus J 290.5 into S minus of minus 125 minus J 290.5. Now we can multiply this negative inside. So that 0.2 into S plus 125, minus minus become plus. This minus plus become minus, minus J 290.5. Similarly, S plus 125 plus J 290.5. Here minus is minus also plus. Here also minus available plus. Now we'll go for the further simplification. So I of S is there. In order to take the inverse Laplace, we need to convert into partial fraction technique, so that we can able to take the inverse Laplace. We cannot take the inverse Laplace of this form. So this equation can be written as K1 divided by S plus 125 minus J 290.5 plus K2 divided by S plus 125 plus J 290.5. So these two terms we need to find K1 and K2. After finding the K1, K2, we can easily take the inverse Laplace transform. So next step is we need to find K1 and K2 value. Thereby we can take inverse Laplace. So these two are both are equal. Both this expression only written like this. So this 500, this term is equal to this term. Both are equal. Now we will take the LCM. LCM on this side. These two terms will take the LCM for further simplification. Right, these two terms are taken. Here this term is available, this term not available, so multiplied here. Similarly here J plus 125 plus 290 available, this term not available, so it is multiplied here. So this term is multiplied with K1, this term is multiplied with K2. Right, now these two terms available on both the side, so got cancelled. So finally what we have, 500 equal to K1 into this term plus K2 into this term. Here plus plus, here plus minus. This equation number 1. Right. So finally we got the simplified equation. So now we need to find the value of K1 and K2. So how will you find the K1 and K2? If we substitute S equal to minus 125 plus J 290.5. See here the plus is available. Plus 125 minus J 290.5. Just opposite to that, minus 125 plus J 290.5. If you substitute that, this K2 value automatically got cancelled, so that we can able to find K1. Similarly, if we substitute minus 125 minus 290 means this term got cancelled, so that we are able to find K2. Right. So this value is decided accordingly to cancel any one term, either K1 or K2. So by substituting this value, this K2 term become 0. So I will substitute this value. S equal to minus 125 plus J 290.5 equal to 500 equal to K1 into this S value minus 125 plus J 290.5. Already here 125 available plus J 290.5 available plus K2 into minus 125 plus J 290.5. But here what is available? Plus 125 minus 290.5. These two terms got cancelled and these two terms got cancelled. Here also minus 125 plus 125 got cancelled. Only we have J 290.5. Here one more J 290.5. Right. So this K2 is 0. So by adding these two we got 581. 500 equal to J 581 K1. Now from that we need to find the K1 value. What is the value of K1? So K1 you can bring this term in the denominator. So 500 divided by J 581. In order to remove this J term, we multiply and divide by the J. The term J is multiplied and divided in order to bring this complex term in the numerator. So 500 J equal to 581 J square. We know that J square is minus 1. So 500 divided by 581 minus. So 500 divided by 581 is 0.86. Minus is there, so minus J. So K1 equal to minus J 0.86. Similarly, we can find the K2 value. We need to substitute the S equal to minus 125 minus J 290.5. So that we can cancel K1, we can able to find K2. So this value is substituted here. K1 and K2 S value substituted. Here these two are cancelled. These two terms also got cancelled. Here 125 got cancelled. So automatically this term is 0. K1 is 0. So we have to choose the S value such that in previous case K2 term becomes 0. In this case K1 term becomes 0. Accordingly we have to choose the S value. Now here also same thing. Minus, but here minus J 581 is available. So 500 equal to K2 into minus 581 J. So K2 equal to minus 500 divided by 581 J. Here also multiplied and divided by J. Now we'll go for further simplification. So that is 500 J divided by 581 J square. So minus 500 J 581 J square is minus 1. So minus minus got cancelled. 500 divided by 581 is 0.86. Similar to previous case, only here their negative is there. Now here also negative is removed. Right? J 0.86. K1 is minus J 0.86. Here already one minus is there, so it become plus J 0.86. So we can substitute this value. This is the equation what we are using, the partial technique, partial fraction technique, K1 by this term. Now we can substitute K1 and K2 value. So after substituting what we got, minus J 0.86 divided by this term plus J 0.86 divided by this term. So by taking the inverse Laplace on both the side, we will get the transient current. That is our question. We need to find the transient current. So I of S, inverse Laplace of I of S is I of t. Right. Minus J 0.86 is constant. This 1 divided by S plus 125 minus J 290.5 can be written as this, based on this, e power minus at equal to 1 divided by S plus a. Right. Here a is nothing but 125 minus J 290.5. So that it is e power minus, this is a into t. Here also J 0.86 same thing, minus 126 plus J 290.5, where both the term is different. 125 minus is there, here 125 plus is there. Both the case we applied this value. E of minus 8 is 1 divided by S plus a. Here plus means here minus. Right. Now we got the inverse Laplace in the time domain. Now we can go for the further simplification. So this term is written. This again the term is written. Now we can split the term in order to for further simplification. Minus J 0.86 e power minus 125 t. Here t is available. T is multiplied. E power J 290.5 into t. So here also it is multiplied. Right. So e power minus 125 available in both the terms. So that taken outside. Here e power J 290.5 minus e power minus J 290.5. Both are different. Here plus, here minus. This term is commonly available. Right. So this term can be written as 2J sin 290.5. So that is based on the expression is available. E power j theta minus e power minus j theta divided by 2j equal to sine theta. So this is the formula. This multiply this 2j that side, so that e power j theta minus e power minus j theta can be written as 2j sine theta. Here theta is nothing but 290.5. So based on that, this value e power j theta minus e power minus j theta, these two terms. This theta is nothing but 290.5. So that can be written as 2j into sine theta. Theta is 290.5 t. Right. Now here the minus j, here also one j is available. J available 2 times. So j square. Already here one minus is there. 0.86 into 2. Here 2 is there. 2 e power minus 125 sine 290.5. We know that j square is minus 1. 0.86 into 2 is 1.72. Right. So j minus minus become plus. So finally 1.72 e power minus 125t into sine 290.5 t. So this is the transient current of the given RLC circuit. So in this video I will discuss the solved problem for the RLC circuit. First we will identify the current, this underdamped condition. Then it is decided it is complex conjugate, third case. Based on that we framed the equation. Using partial fraction technique, we split the equation, we identify k1 and k2 value. After that we taken the inverse Laplace. After simplifying that, finally we got the transient current I of t. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the DC transient response of RLC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the problem. RLC circuit, DC transient response of RLC circuit, problem number 2. We'll see the statement of the problem. A series RLC circuit with R equal to 300 ohm, L equal to 1 Henry and C equal to 100 into 10 to the power minus 6 farad has a constant voltage of 50 voltage applied to it and t equal to 0. Find the value of current. So series RLC circuit available, RLC values are given, the voltage is applied 50 voltage at t equal to 0. We need to find the current, value of the current. So after t seconds of applying the voltage, we can get the following equation. By using the Kirchhoff's voltage law, we can get the equation of RLC circuit. R and LC are connected in series. So based on the KVL, the applied voltage E equal to voltage drop across resistor, inductor and capacitor. Voltage rise equal to voltage drop. That is the basic of the Kirchhoff's voltage law. So R into I, voltage drop across resistor is R into I, plus inductor is L di by dt plus 1 by C integral I dt equal to E. That is the equation number 1. Our aim is to find the transient current. So first we'll substitute the values. R is 300, L is 1, C is 100 into 10 to the power minus 6 and E is 50 voltage. So after simplification, 300I plus di by dt plus 10 to the power 4. 100 into 10 to the power minus 6 is 10 to the power minus 4. While going to numerator, it becomes 10 to the power 4. I dt, integral I dt equal to 50. We will take this equation number 2. Now we need to take the Laplace transform on both the sides to convert t domain into s domain. Again after simplification we need to take inverse Laplace. Again for that we need to get the transient current. So first we will take the Laplace transformation on both the sides of the equation number 1. So 300 is constant, I is I of s. Laplace transform of I is I of s. Laplace transform of di by dt is s into I of s minus initial current I 0 plus. Then 10 to the power 4 is constant. Integral I dt. Laplace transform of integral I dt is I of s divided by s. 50 is constant. The Laplace transform of constant is 1 by s. So 50 divided by s. Differentiation means s into I of s. Integral I of s divided by s. We know that the initial current is 0. That is not given in the problem. We assume that the initial current before closing the switch is 0. So based on that, 300 I of s, s into I of s. This term is 0. Plus 10 to the power 4 I of s divided by s equal to 50 by s. I will take the I of s outside. So 300 plus s plus 10 to the power 4 by s equal to 50 by s. I will take this s commonly, LCM. So here s is not available, so 300 s. Here also s is not available in the denominator. S into s, s square. Here s is available 10 to the power 4. So this s is cancelled on both the side. So after cancellation, what we got? I of s of 300s plus s square plus 10 to the power 4 equal to 50. Bring this term in the denominator, that side. So that will get I of s. 50 divided by s square plus 300s plus 10 to the power 4. We'll take this equation number 3. So in the denominator, this is nothing but a quadratic equation. We need to simplify this so that we can take the inverse Laplace. We cannot take the inverse Laplace of this form. We need to convert into standard form. S square plus 300s plus 10 to the power 4 equal to 0. We will equate this quadratic equation equal to 0. We will compare with the standard equation. Ax square plus bx plus c equal to 0. This is a standard. Here x is nothing but s. A is nothing but 1. B is 300. C is 10 to the power 4. Now we will go for the solving this quadratic equation, so that we will get the two different roots. Now we will go for solution of this quadratic equation. So we know that the standard formula is s equal to, otherwise x equal to, here we are using s equal to minus b plus or minus b square minus 4ac divided by 2a. So we can get the solution of this quadratic equation by using this formula. So s equal to b is 300 plus or minus b square, 300 square minus 4 into a value is 1, c value is 10 to the power 4 divided by 2a, 2 into a is 1. So minus 300 plus or minus square root of 300 square is 90,000 minus 4 into 10 to the power 4, that is 40,000 divided by 2. So 90,000 minus 40,000 is 50,000, square root of 50,000. So minus 300 plus or minus square root of this 50,000 is 223.61 divided by 2. Here plus or minus is there. Based on that, we will get the two different roots. Now we will split the roots. Minus 300, now split this 2. Minus 300 divided by 2 plus or minus 223.61 divided by 2. This 2 is splitted. So minus 300 by 2 is minus 150 plus or minus 223.61 divided by 2 is 111.8. Now we can write the two different roots. Minus 150 plus 118.8. Minus 150 minus 118.8. So this value is minus 38.2. This value is minus 261.8. So this is the S2 value. So S equal to minus 38.2. So we'll bring this term this side. S plus 38.2 equal to 0. Similarly, bring this term this side. So S plus 261.8 equal to 0. Right? Now this quadratic equation is written in the another form with the two different roots. This is S equal to. While writing the root, we need to bring this term this side. Similarly this side. So it becomes plus. Right. Now we got this simplified form. So that the equation 3 we can write the equation 3 as 50 divided by s square plus 300s plus 10 to the power 4. This is the equation 3. So this term now can be replaced by these two roots. S plus 38.2 into s plus 261.8. Now we need to go for the partial fraction technique in order to split the term. Then only we can take the inverse Laplace. We can take this inverse Laplace easily. We cannot take the inverse Laplace of this form. So that it is splitted by using the partial fraction technique. So here we introduce k1 divided by s plus 38.2 plus K2 divided by S plus 261.8. So before taking the inverse Laplace, we need to find the value of K1 and K2, right? So this equation is written like this by using the partial fraction technique. Now we'll go for the further simplification. So this equation 50 divided by S plus 38.2 into S plus 261.8 is written as K1 divided by S plus 38.2 plus K2 divided by S plus 261.8. Now we'll take the LCM on this side. We'll take these two terms. Here 38.2 is not available. This term is not available, so it is multiplied. K1 into S plus 261.8. Here 261 available. This term is not available, so it is multiplied. Right? So out of two terms, one term is not available, so it is cross multiplied. So these terms are available on both the sides. So they got cancelled. So after cancellation, what we got? 50 equal to K1 into S plus 261.8 plus K2 S plus 38.2. We'll take this equation number 4. Now our aim is to find the value of K1 and K2. We need to select the S value such that one term got cancelled. For example, if you put S equal to minus 38.2, here plus 38.2 is there. If you put S equal to minus 38.2, this K2 term become 0, so that we are able to find K1. Similarly, if you put minus 261.8, this term got cancelled, so that we can find K2. Right? So the S value is selected such a way that one term got cancelled. So first we will substitute minus 38.2 in this equation number 4. So 50 equal to K1 into S value minus 38.2 plus 261.8 plus K2 into minus 38.2 plus 38.2. So this term become 0. This term is 223.6. That is 50 equal to 223.6. So that into K1. K1 equal to 50 divided by 223.6. So that is nothing but 0.2236 K1 value. Similarly, we can find the K2 value. So now we are substituting minus 261.8, so that we can cancel K1 and we can able to find K2. 50 equal to K1 into minus 261.8 plus 261.8 plus K2 into minus 261.8 plus 38.2. So this term become 0. This term is 223.6 minus 223.6. That is 50 equal to minus K2 into 223.6. That is 50 equal to minus 223.6 K2. So K2 equal to 50 divided by 223.6. That value is minus 0.2236. So K1 is plus 0.2236. K2 is minus 0.2236. 2236. Now this is the equation what we discussed, partial fraction. Now we can substitute the value of K1 and K2, so that we can go further for inverse Laplace. So K1 is 0.2236, K2 is minus 0.2236. Right. So we can write like this. This 0.2236 available commonly. We can take outside. 1 divided by S plus 38.2 minus, due to this minus here minus 1 divided by S plus 261.8. Now we can take the inverse Laplace easily. This form, this is a standard form. Based on this, 1 divided by S plus A is e power minus at. Here plus means minus, minus means plus. So this is very similar to 1 divided by S plus A. A is 38.2. Similarly, here A is 261.8. So based on that, we can write e power minus at, e power minus 38.2 t minus e power minus 261.8. So this is the final equation. Transient current of the RLC series circuit. Right. The final equation. Now we'll go for the maximum value. So it is required to find the maximum value of I of t, transient current. How to get the maximum value? Differentiate di by dt and equate to 0. We'll get the value of t At this value of t, if di square by dt is negative, then I of t is maximum. So it is based on the maximum minimum theorem. We have to find the di by dt and equate to 0, so that we will get the t value. That t value is substituted in this di square, so that will give a maximum, right? So now we'll go for di by dt, that equated to 0, in order to get the time at which the current is maximum. So d by dt of this value, this is the I of t. The constant available outside is 0. So e power minus 38.2t minus e power minus 261.8t equal to 0. Now we have to differentiate. While differentiating, this term become available at the front side. E of x is x e of x. Differentiation of e of x is x into e of x. Similarly, here x is 38 point. Based on that, minus 38.2 e power minus 38.2 t minus of minus 261.8 e power minus 261.8 t equal to 0, right? So differentiation of e of x value is nothing but x e of x, right? This x will come in the front side. Based on that, it is written. Now we'll go for the further simplification. So minus 38.2 e power minus 38.2, here both are negative, become positive. So bring this term that side, so it become plus, minus become plus. So the both the side we have. Now bring this 38 point in the denominator. In our aim is to find the t value. So this term is brought here, and this term is brought in the denominator, that side. This term is brought to this side. So after simplification, we got 6.853 equal to e power 223.60. The final equation. Now we need to find the value of t value. Our aim is to find the t value. So take log on both the side with base e. So log 6.853 base e equal to log e power 223.60 base e, right? So this, the value of this is 1.925. What is this value? Log of e power x is nothing but x log power e. This power will come in the front side. So based on that, it is come. Then log e base e, this value is 1. We know that log e base e. Well, now bring this term in the denominator. So t equal to 1.925 divided by 223.6. By simplification, we got 8.6 into 10 to the power minus 3 seconds. So the current will be maximum at the time of, the time is 8.6 into 10 to the power minus 3 seconds. At this time, the current become maximum. So based on that, we can write I of t max. Yes, this is the I of t. In that I of t max is, you have to substitute the t as 8.6 into 10 to the power minus, so that it become I of t max. I of t max equal to the value of I of t at 8.6 into 10 to the power minus 3 seconds. Now the t value is substituted, 8.6 into 10 to the power 3. Then it is multiplied, then simplified. Finally we got 0.2236 of 0.72. This value, e power this value is 0.72. This value is 0.015. So after subtraction and multiplication, we got 0.1378 amperes. So the maximum value of current. After simplification, we got 0.1378. This is the maximum value of current. So in this video, we discussed the solved problem based on the RLC circuit. We framed the equation using KVL. Then we take the Laplace transformation. By quadratic equation, we solved. Then we are using partial fraction technique. We splitted the equation. Thereby we calculated K1 and K2. After that, we take the inverse Laplace, so that we got the transient current. In order to find the maximum value of current, di by dt is equated to 0, so that we got the time period t value at which the current is maximum. That t value is substituted in the transient current to get the maximum value of current. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.